Assalamu alaikum. We know vectors have both the magnitude and direction. So they cannot be added by ordinary methods. In order to add vectors, we follow either graphical or geometrical methods. In this video, we will discuss a geometrical method to add vectors. When we talk about a geometrical method, there are two methods are available to add vectors. One is the triangle law of addition of vectors. Second one is parallelogram law of addition of vectors. In this video, we will discuss triangle law of addition of vectors. Usually, triangle law of addition of vectors and parallelogram law of vector both are used to add vectors which are inclined to each other. In order to explain this method of addition of vectors, I take two vectors. I consider two vectors, vector A and vector B. Vector B. These two vectors are inclined to each other. Now I am going to apply triangle law of vectors to these two vectors in order to get the resultant of these two things. For that, I draw a line whose length is equal to that of a vector E. I name this line as bow A. This is the head of this vector. Now, this line bow A represents vector A. Then, look at carefully what I do. I take this vector to this end of this line. Okay. Actually, I am going to draw one more line. I name this line as AB. Now, while doing so, care must be taken that the angle of this line should be equal to the angle that this line make with the first vector. Clear? So, it has to be drawn. Now, this line is named as AB and it represents vector B. Okay. Now, why I have done so? If you look at this diagram carefully, you will find that the second line starts from the head of first vector, or I can say the tail of second vector is compared to the head of first vector. So we have taken them in order. They are taken in order. Now I am going to close this to get a triangle. How this can be closed? This can be closed by drawing a line from the tail of vector A and it moves towards the head of vector B. Yeah. See, if you want to draw a line to complete the triangle and I want to go in order, then I should have drawn this line not towards O, but I have done the reverse thing. The third line, which represents the resultant of vector A and B, is taken in reversed order. Remember this. So we call this method of arranging of vectors to form a triangle is known as triangle of vectors. Okay. Anyhow, we have got one triangle here. Now this line whose length is equivalent to the magnitude of A plus B. Clear? So I name this one as R vector. This resultant vector is named as R vector, which is equal to A vector plus B vector. Now I will find out the magnitude of resultant vector. Then after doing so, I will find out its direction. Clear? Now let's do it. In order to find out the resultant of this resultant, the magnitude of this resultant vector, I drop a line. I drop a perpendicular from this point also, see, from point B, from the head of B. I am dropping a line in the downward direction. Then I extend this line over here. Now we are at this point. These two lines intersect. The intersecting point. I name this intersecting point as N. So here I have got a right angled triangle. We got a two right angled triangle. OBN and ABN. Okay. When do we call a triangle as right angled triangle? There is a condition. If any one of the angle that the triangle possesses is equal to 90 degree, then we call such triangle as right angled triangle. Clear? So this is a right angled triangle. Now from this diagram I take a triangle ABN, triangle ABN. I try to find out the value of sine theta. What is sine theta here? See? We know sine theta is nothing but opposite side divided by hypotenuse. So actually, I have taken this triangle. For convenience, I am going to draw this triangle here. Yeah. A, this is B, this is N. This is right angle triangle. And in a right angled triangle, here this is I take this angle as theta. Take this angle as theta. The side of the triangle which is present opposite to this angle is referred as opposite side. And this side of the triangle which is adjacent to this angle is called as adjacent side. Adjacent side. Okay, and the side which is left as such is named as hypotenuse. It is hypotenuse. H by P right here. Hypotenuse. So this side is the opposite side, adjacent side, and this side is called as hypotenuse for the triangle. Okay, so I'm going to mention the value. What is the opposite here? The side is nothing but B N, and the hypotenuse is A B. A B. Okay. Now what is the value of BN. I don't know what the value of BN, but we know the value of AB. This hypotenuse value is known to us. That is nothing but B. No? The value of AB, that is the hypotenuse is B, is mentioned here from the diagram. But we don't know what is the BN, so it is left as such. Now from this expression, see, one can get the value of BN easily. Now keep BN. We rewrite this, send it as equal to BN upon B. So next step, cross multiply this. BN is kept one side and B is taken that side. So what I get is B multiplied with sine theta. Okay, here B is in denominator. When it is taken to the other side, it will multiply. That's why for better visibility, I box this equation. Okay, I name this one as equation number 1. Right, then I go ahead. I'm going to find out the value of cos theta. The formula for cos theta is adjacent side divided by hypotenuse. What is adjacent side here? Adjacent side is AN. The hypotenuse is AB. The value of AB is B. And we don't know the value of AN. Okay, then by following the same method as we did in the previous step. Here AN is found to be equal to B cos theta. B cos theta. So here cos theta is equal to AN upon B. Now to find the value of AN, I need to take B to the other side. So this B will multiply with cos theta. We obtained this equation. I box this. And I name this equation as equation number 2. Equation number 2. Okay, so we got 2 equations now. Now I'll go ahead. Then I'll take this entire triangle now. Take a triangle. Triangle OBN. Is that I will draw this triangle here. This is the triangle. This O, this B, this is the jet. Okay, and here we have A. Okay, so this is the value of OB is R, and BN value is here. There is a B sin theta, and the value of AN, this one, the value of AN is B cos theta. Okay. Then we have rho A. The value of rho A is nothing but A R. Okay. To differentiate this, I'm giving a different color for AN. Alright. This is what we obtained from this diagram. Clear? Then for this right angle triangle, I am going to apply Pythagoras theorem. Applying Pythagoras theorem. Pythagoras theorem. Let's see what we get. What does Pythagoras theorem say? What is the Pythagoras theorem? This square of adjacent side is equal to sum of square of remaining sides. Sorry, square of hypotenuse is equal to square of sum of square of remaining sides. Okay. So OB square will be equal to ON square plus BN square. BN square. Now, what is ON? ON is nothing but the addition of OA and AN. Okay. So here, write it like this. OB square is equal to OA plus AN. In the place of ON, I have written OA plus AN. It is obvious from this diagram. Now, I square it. Clear? Then here BN square. Then in the next step, let's see what I am going to do. I am going to write the value of AN and the BN. Okay, let's do it. That we have in equation number 1 and 2. Here from the above equation. Before doing so, let me box this. I box this. Then I name this one as equation number 3. Name this one as equation number 3. Now I'll substitute equation 1 and 2 in the 3. Substituting 1 and 2 in 3. What happens if I do so? Let's find out. If I substitute OB as such, OB square, that OA. What is the value of OA? OA is nothing but A. Okay, now I write. OA is nothing but A plus, what is AN? AN is B cos theta from equation number 2. B cos theta whole square plus, what is BN? BN is nothing but B sin theta. B sin theta. I square it. Okay, whole square. Right, this is what we have obtained. This is the value of OB square. If you want, I can also mention the value of OB. What is OB here? OB is nothing but R. So, OB is R from the diagram. Okay. Substituting the value of OB is equal to R. Now, if I do so, here in this equation, what I will get? Now, look at this. Right, right? You see, the place of OB I mentioned its value, which is nothing but R. So R square is equal to A plus B cos theta whole square plus, so expand this, expansion B sin theta whole square becomes B square sin square theta. Okay. Now we know this trigonometric identity is that A plus B whole square is equal to A square plus b square plus 2ab. A square plus b square plus 2ab. This is the trigonometric identity. This I am going to apply here. This I am going to apply here. This place. Let's do it. Here r square. Right? Here an expansion becomes a square plus b square cos square theta plus 2ab cos theta. Okay, plus this term is written as such b square sin square theta. Okay, now I'm going to rearrange this. How? Something like this. R square is equal to b square plus. Now here in this two term b square is common, so b square is taken out. Then get sin square. So I skip one step here. Sin square theta plus cos square theta plus 2ab cos theta is what we have taken. Okay, go ahead. Now we know sin square theta plus cos square theta is equal to 1. In trigonometry you might have learned the addition of sin square theta with the cos square theta gives us 1. So in the next step you get this square plus b square. In the place of this you get 1 plus 2ab cos theta. So we know whenever we multiply something with 1, the value remains as such. So b square multiplying with 1, you get b square. So r square is equal to b square plus square plus 2ab cos theta is what you get at the end. Okay, this gives us the magnitude of resultant vector. Now I can go one step further. From this r value can be obtained by taking square root. Taking square root both sides. To take a square both sides, square root of r square becomes r, and here with this root of a square plus b square plus 2ab cos theta. This is the final expression, and it gives us magnitude of resultant vector. Okay. I box this final expression. Now I am going to find out the direction of this resultant vector r. Okay, direction of resultant vector. Direction of resultant vector. Here, you remember this. Direction of a given vector can be obtained by the angle that it subtends with the another vector. Okay. So here in this diagram, the direction of r vector can be obtained if we know the angle between A vector and R vector. Okay? And here, for my convenience, I take the angle between A vector and R vector to be equal to alpha. This is the angle between A vector and R vector, and it gives us the direction of resultant vector. Okay, so I will draw this diagram here. This is O, that is N. This point is B. This is R vector. This is the right angle triangle. Okay, and here the angle is alpha. Now I want to find out this angle. For that, I take tan of angle alpha. You know the formula of tan theta or tan alpha. But opposite side divided by adjacent side. Opposite divided by adjacent side. What is the opposite here? Opposite is nothing but B here from the diagram. This is the opposite. And adjacent side is O here. Okay. The next step, I'm going to substitute the value of Bn and Ol from here. What is the value of Bn? Bn is B sin theta, and On is the value of On is Oa plus An. Okay, that I will substitute here. This will be switch. As Bn, On is equal to Oa plus An. A is the value of tan alpha. Okay. Then I'll substitute the value of Bn, Oa and An from the previous equations. From here, the value of Bn is obtained, and from equation number 2, we get the value of An. Then the value of Oa is nothing but A. Okay. Substituting the value of if it is B and B sin theta, and the value is B. I take only the magnitude, and the A value is the B cos theta. B cos theta. This is the final expression that we have taken. Then, say my aim is to get the value of alpha, isn't it? So, that I do. So, to get the value of alpha, I keep alpha here as such, and tan is taken to the other side. If I do so, I get this alpha is equal to tan inverse. Yeah, when tan is taken to the other side, it becomes tan inverse. I write this part as such: B sin theta divided by A plus B cos theta is the final expression. If you want, you can box this for better visibility. Let me do it. This is the final expression, which gives us the direction of resultant vector R. This is how one can easily find out the magnitude and the direction of a resultant vector. Or this is the simple method of adding two vectors using triangle law of addition of vectors. I hope the video is useful. If you have any kind of doubt related to the topic, can you put your questions in the comment section. Thanks for watching.